Conjugate root theorem. The conjugate root theorem states that if p of x is a polynomial with rational coefficients, then the irrational roots of p of x equals 0 occur in conjugate pairs. That means that if a plus the square root of b is a root, then a minus the square root of b is also a root of the function. If p of x is a polynomial with real coefficients, then the complex roots of p of x equals 0 occur in conjugate pairs. And that means that if a plus bi is a root, then a minus bi is also a root. So here we're just going to practice writing the conjugate of each root. If we have 1 plus 3i, 1 minus 3i will also be a root. Negative 4 minus square root of 7, so negative 4 plus the square root of 7 will also be a root of the function. And you need to be careful here because we're not changing the sign of the first one, we're just changing the sign of either that irrational number or the complex number. So I want you to try example 3 and 4 and check back with me when you're finished. Hopefully for example 3 you got negative 2 plus 9i, and example 4 you got 15 minus square root of 10. So what this means is that as we continue writing polynomial equations from the roots, if you're given a complex root or an irrational root, you have to automatically add the conjugate as well. Now let's talk about how to turn those conjugate roots into factors. They're going to be a little different from the roots that we turned into factors in the previous lesson. So first, we want to line up our conjugate roots vertically and add them down. So I'm going to take 2 plus the square root of 3, and then 2 minus the square root of 3, and we're going to add downwards. So 2 plus 2 is 4. Square root of 3 minus the square root of 3, that becomes 0. So we actually just have 4. This is going to represent our m value in our final answer. Then, step 2, multiply or FOIL the conjugate roots. So let's take 2 plus the square root of 3, and then we're going to multiply that with 2 minus the square root of 3. So we need to FOIL this. So the first terms, 2 times 2 is 4. The last terms, 2 times negative root 3 is negative 2 root 3. The inside terms is positive 2 root 3. And then the last terms, positive root 3 times negative root 3 just gives us negative 3. Now what you'll notice is that the middle terms are always going to cancel out. Negative 2 root 3 plus 2 root 3 is going to give us 0, so we're really just left with 4 minus 3, and that gives us 1. That's going to be our answer for n, our value for n in our final part. So in part 3, we need to combine the answers from part 1 and part 2 into a trinomial of this form. So I'm going to go ahead and start by writing x squared, and then I'm going to put an x and then close my parentheses. Then it says this minus m, that's going to be our answer from part 1, but with the opposite sign. So our answer from part 1 was positive 4, and we're going to use the opposite sign, negative 4, as the coefficient for our x term. Then this plus n at the end, that's our answer from part 2 with the same sign. So since we had a positive 1 in part 2, that's going to be our third term in our trinomial. So this is going to be one of the trinomials that we use in finding our final polynomial equation. Here we just want to practice finding the conjugate root and making the conjugate pairs into a factor. So in the first example, we have 2 minus 5i, and then the conjugate root would be 2 plus 5i. Now we want to take these and follow the steps we did before to find our trinomial factor. So first we're going to line them up and add them, 2 minus 5i, and then 2 plus 5i. And then when we add down, we get 4, and then these cancel out, so we're actually just left with 4. Then we want to FOIL our two pairs. So we have 2 minus 5i times 2 plus 5i. So when we FOIL this, we get 2 times 2 is 4. We get a positive 10i, a negative 10i, and then a negative 25i squared. So make sure you're multiplying carefully as you FOIL. Then this middle term is going to cancel out, positive 10i minus 10i. So we're left with 4. Now remember, I squared is really the square root of negative 1 squared. So I squared is the same thing as negative 1. So when we multiply negative 25 times negative 1, you actually get a positive 25. So our answer to part 2 is actually going to be 29. So then we can go ahead and write our final factor, our trinomial. It starts off with x squared, and then we want to take the opposite sign from part 1, so a negative 4x, and then the same sign of part 2 plus 29. And this is going to be our trinomial we'll use to find our polynomial equation. So I want you to pause, try this with example 2, and check back with me when you finish. So the first part is finding the conjugate root, negative 4 minus square root of 7. So remember, you're only changing the sign of either the irrational or the complex part of the root. You're not changing the first one. So in part 1, when you add straight down, you should get negative 8. When you FOIL the two conjugate pairs, you should get positive 19. So when you combine them for your trinomial, you should have x squared plus 8x plus 19. So don't forget the signs. Now how do we pull all of this together? So we're going to take some ideas from today and some from a previous lesson so that we can write a polynomial with rational coefficients so that p of x equals 0 has these given roots. So we want to walk through the roots of 5 and 6i. So we know that as soon as we see 6i, that means that negative 6i is also going to be a root. So let's go ahead and work with this part first. And that's what we've been doing in this lesson so far. So first, let's add down 6i minus 6i, and that gives us 0. And then we're going to multiply those, 6i times negative 6i. And in this case, because it's just one term, we don't need to FOIL, we're just going to multiply. This gives us a negative 36i squared. And remember, we always substitute I squared with negative 1. So negative 36 times negative 1 gives us positive 36. So when we write our trinomial, it's going to be x squared and then minus 0x plus 36. Now we don't really write 0x, so we're just going to take that out, and we actually have x squared plus 36 as one of our factors. So we're going to take that factor, x squared plus 36, and then we need to multiply that with our other root. So if we take the root of 5 and turn that into a factor, remember this is from our previous lesson, x, and that becomes minus 5. Now we need to multiply these two binomials. So we're going to FOIL these. First terms, we get x cubed. Outside terms, negative 5x squared. Inside terms, plus 36x. And then last terms, negative 180. And then you check to see if there's anything that you can simplify, and we don't have any like terms, so this is actually going to be your final answer. We have the function p of x equal to x cubed minus 5x squared plus 36x minus 180. And here is our polynomial equation. So let's walk through this one more time together, and I made this one a little more complicated, so we'll go through it step by step again. So let's go ahead and deal with the conjugate roots first. When we have 1 minus square root of 5, that means 1 plus square root of 5 is also going to be a root. So let's go ahead and combine these together first. So we have 1 minus square root of 5, and then 1 plus square root of 5. So when we add down, we get 2, because that cancels. And then we want to multiply these. 1 plus square root of 5 times 1 minus square root of 5. So multiply the first, the outer, the inner, and the last. And then the middle terms will cancel out, so we have 1 minus 5, which gives us negative 4. And then we want to write that factor, x squared minus 2x minus 4. Now before we bring that in to combine it with our other factor, let's take a look at our other roots. It says negative 2 dr. That dr stands for double root. So that means that actually that root of negative 2 occurs twice. So let's work with that. We have x plus 2 when we turn it into a factor, and x plus 2. So let's go ahead and multiply these first. We have x squared plus 2x plus 2x plus 4. And then we can combine like terms, so we get x squared plus 4x plus 4. Now we want to take these two trinomials, this one from our double root of negative 2 and this one from our conjugate roots, and we're going to multiply those together. So before we start multiplying, I'm just going to move some of these around so that I have a little more space to work. So when I move that down here, we really want to focus on these two trinomials. So I just made a little dividing line to keep my stuff separate. So let's go ahead and take this x squared term and multiply by each of the terms here. So we have x to the 4th, and then minus 2x cubed, and then minus 4x squared. And then we'll take the second term, multiply by each one. That's a positive 4x cubed, and then a negative 8x squared, and a negative 16x. And then we're going to need to move in, take this third term, and then multiply by each one, so we get plus 4x squared minus 8x, and then minus 16. And then lastly, we need to combine any like terms that we have. So we only have one term with an x to the 4th. And then we have this term x to the cubed and x to the cubed, which gives us plus 2x cubed, x squared, x squared, x squared. So that's minus 4 plus 4, which gives us 0. So we're left with negative 8x squared. We have a negative 16x and a negative 8x, which gives us negative 24x. And then lastly, a minus 16 as our constant. Now, the only thing that we're missing for our final answer, let me move this a little, is to put a p of x equals in the beginning. And here is our polynomial function with negative 2 as a double root and 1 minus square root of 5 and 1 plus square root of 5 as the roots. That's it. We'll get in a lot more practice in class. so come with questions.